This lesson is on symmetry and even and odd functions.
Okay, so to understand even and odd functions, you need to know what line symmetry is. So line symmetry is the vertical line over which the function is mirrored, and basically all quadratics with degree 2 have line symmetry, and these are two examples of quadratics that would have line symmetry.
The other type of symmetry that's used is point symmetry. So this is a point over which the function remains symmetrical when rotated 90 degrees. And all cubics, which have a degree of 3, have point symmetry. And these are two examples of graphs that have point symmetry.
Okay, so now that we learned about line and point symmetry, we're ready to learn about even and odd functions. So even functions have line symmetry over the x-axis, and there's two ways to solve this, which are graphically and algebraically. So to solve this graphically, you can check if the function is mirrored over the y-axis.
To solve algebraically, check if in the equation in standard form all the exponents on x are even, and if there's a constant or not, that's okay, it doesn't matter. Also, if you plug in negative values for x, you would get the original equation back out.
So now we're going to learn about odd functions. So odd functions are when there's point symmetry over the origin, which is at 0, 0. So you can solve odd functions in two ways, which are graphically and algebraically. So to solve an odd function graphically, you look for the origin and see if the function can be rotated and still be symmetrical.
To solve an odd function algebraically, first make sure that all the exponents on the x's are odd when the equation is in standard form, and there cannot be any constant. Also, when you plug in a negative value for x in the original equation, all the signs of the original equation will flip, and you can tell that it's an odd function.
So the functions can also have no symmetry. So no symmetry occurs when there's no line or point symmetry on the function. Therefore, the function is neither even nor odd. So you can find this algebraically by looking for a mixture of even and odd exponents on the x's. And this is a graph that has no line or point symmetry, so you can tell that it has no symmetry at all. So now we're going to do some examples on how to solve even and odd functions. So here's an example of how to solve an even function graphically and algebraically. So to solve it graphically, you can tell that this is an even function because it's symmetrical on both sides of the y-axis.
We can also see in the equation that both of the exponents on the x values are even. Therefore, the function is probably an even function. And to solve this algebraically, if we were to plug in a negative value for x, we would get negative x to the power of 4 minus 3 times negative x squared plus 4. And when we simplify this, it would just end up being x to the 4 minus 3 times x squared plus 4, which is just the original equation. Therefore, we can see that this is an even function.
Okay, so now we're going to do some examples of odd functions. So for the odd function example, we're going to solve this graphically and algebraically as well. So to solve this graphically, you can look for a point on the origin, and if the function can rotate and still be symmetrical, you know that's an odd function.
To solve it algebraically, first we can see in the equation that all the exponents on the x's are odd numbers, so 5, 3, and 1. Also, if we were to plug in a negative value for x, we would get negative x to the 5 minus 2 times negative x to the 3 plus 7 times negative x. And this would just simplify to negative x to the 5 plus 2x 3 minus 7x. And you can see that these are the opposite signs from the original equation, so that's how we can tell that it's an odd function algebraically.
Okay, so now we have our final example of how to solve a function that has no symmetry at all. So we're going to solve this graphically and algebraically. So graphically, you can tell this function has no symmetry because it doesn't have point symmetry or line symmetry. So we know that it's not even or odd.
We can also solve this algebraically because we can see on the x coordinates there's a mixture of both even and odd exponents, so 6 and 1. Also, if we were to plug in a negative value for x, we would get negative 2, negative x to the 6 minus 3, negative x plus 4. And this would just simplify to negative 2x6 plus 3x plus 4. And as we can see, not all of the signs switch and not all of the signs stay the same. So therefore, it's neither an even function or odd function, so that means there's no symmetry at all.